Welcome to this presentation on work done in a spring and elastic material. We will explore Hooke's law, learn how to calculate work done, and solve practical examples step by step. Let's begin. In physics, work is said to be done when a force causes an object to move in the direction of that force. Springs and elastic materials are common in mechanical systems. They store energy when they are stretched or compressed. This leads us to Hooke's law. Hooke's law tells us that the extension or compression of a spring is directly proportional to the force applied, but only if the spring is not stretched beyond its elastic limit. Mathematically, Hooke's law is expressed as F equals K times X. F is the force applied in newtons, K is the spring constant in newtons per meter, and X is the extension or compression in meters. The work done in stretching or compressing a spring is given by half times force times extension. Substituting Hooke's law into this, we get that work done equals half times the spring constant times the extension squared. Let's solve our first example. A spring has a force constant 50 Newton per meter. It is stretched by 0.2 meters. Calculate the work done in stretching the spring. We are given a spring with spring constant of 50 newtons per meter and an extension of 0.2 meters. We use the formula for work done, half kx squared. Substituting into the formula, half times 50 times 0.2 squared. 0.2 squared gives 0.04. Then, half of 50 is 25. So we calculate 25 times 0.04. That gives a final answer of 1.0 joules. Let's take a look at another example. A force of 30 Newton is used to stretch a spring with a spring constant of 75 Newton per meter. Find the extension X and the work done. We are given a force of 30 newtons and a spring constant of 75 newtons per meter. Using Hooke's law, X equals F divided by K. We substitute our values. Force of 30 Newton is divided by spring constant of 75 Newton per meter. That gives an extension of 0.4 meters. Now let's calculate work done. We use the formula for work done, which is equal to half kx squared. Substitute into the formula, we have half times 75 times 0.4 squared. That gives a final result of 6.0 joules. Thanks for watching. To deepen your understanding of any topic, explore our comprehensive resources, including revision notes, past questions, gamified quizzes, and workbooks. These tools are designed to help you master the concept effectively and enjoyably.